In this video, I'm going to show you 3 examples of solving a system of equations, and these are going to be linear equations and how they connect together by graphing them. And then what I'm going to do is use my findings in the picture to write a conclusion about the system. Now, in order to graph your lines, the easiest way to graph would probably be to transform your lines into y equals mx plus b format. But you definitely don't have to do that. So I noticed that the 2 forms that I have here are standard form equations, but most of you probably have learned how to graph by solving for y. But you could transform each of these into, or not need to transform these and graph by the intercepts, but it's totally up to you. But I'm going to transform into y equals mx plus b because generally that's how most of you have learned how to graph. So to solve this one for x, I'm going to subtract my 2x term to the other side and separate my y from my x, and now I have negative 2x plus 4. So for this graph, my y-intercept is going to be 4, and then I'm going to follow my slope, which is going to be negative 2. So my first line is going to start on positive 4 on my y-axis, and then we're going to go down 2, right 1, and down 2, right 1, down 2, right 1, and I'm going to continue filling the grid all the way until I have filled it enough with all these points that I can then easily connect with a straight line. So there's our first line from the system. Now the second equation, I'm also going to do the same and solve for y. So in this one, I'm going to subtract my 6x to the other side, and then I'll have 3y is equal to that 6x that we subtracted plus 12, and now I'm going to divide everything by 3. So this equation is going to be negative 2x plus 4. And notice how these 2 equations are exactly the same. So they tried to disguise them as something different, but really they're not. This one's going to start at 4 and go down 2, right 1, down 2, right 1. And what happens is we're going to end up graphing the same line twice here. And so my conclusion is that when you have a system of equations and the equations are the same, those systems, the systems of lines that have the same line will have an infinite number of solutions. And because they share all the points together. And so this is just a unique type of system because your lines don't cross quite like they have in, the other sections here. Other lines, they cross at just one particular point, but it just so happens that this system only tried to disguise a different line as 2 different lines, and then you only graph one line really because the lines, they match. All right, now let's try a second system here. And again, I'm going to solve each of these for y to graph. So I'm going to subtract my 2x, and then I'll have negative y is equal to negative 2x plus 4. And then I'm going to divide everything by negative 1 because I want to have y equals, not negative y. So now I have a positive y. I'll have a positive 2x because a negative divided by negative makes positive. And then 4 divided by negative 1 is going to be negative 4. So my first line, I'm going to have a y-intercept of negative 4, and my slope is going to be positive 2, so up 2, right 1, up 2, right 1. So start at negative 4 on the picture, and then go up 2, right 1, up 2, right 1, up 2, right 1, and continue the pattern until you fill your grid. And then I'll continue going backwards here, so down to left 1. So as best I can, connect those with a straight line. And now I'm going to do the same, solve for y, but on my second equation here. So I'm going to subtract 2x, and now I'm going to have negative y equal to that 2x that I subtracted to the other side, plus the 1 that was already there. And I want to have my x term first, because like I said, I'm getting it in this format, y equals mx plus b. Now again, I'm going to divide everything by negative 1. And I have the function y equals positive 2x minus 1. So my b is going to be down at negative 1, and my m is positive 2, so up 2, right 1, up 2, right 1. So down here at negative 1, and then up to right one, up to right one, up to right one, and continue that pattern to fill my grid. And then down to left one, down to left one, and continue that pattern. And now when I connect these with a line, they never touch. So because I had a system that had identical slope and a different y-intercept, these lines are parallel. And they will never touch. So they have no point in common. So there is no solution here. No solution. So infinite solutions versus no solution. And now let's try one more. So I'm going to start with this equation here, and I'm going to solve for y. So I'll subtract that x to the other side. Now I'll have y equals that negative x that I subtracted plus the 6 that was there. This line, my b, is positive 6, and my m is negative 1. So we're going to start at 6 on the y-axis and then go down one, right one, down one, right one, down one, right one. So here we go at 6, and then down one, right one, and continue putting those points on my grid until I fill up as many as I can in my graph here. And then try to connect those as best you can with a straight line. And then for the next equation here, I'm going to subtract my x to the other side, and I'll have negative y equals that x that I subtracted plus the 4 that was already there. Now I'll divide everything by negative 1, and I'll have y equal to positive 1x, because x divided by 1 is just x, and negative divided by negative is positive. 4 divided by negative 1 is going to be minus 4. So now I'm going to start at negative 4, and I'm going to track my slope, which is positive 1. I have 1x, so up one, right one, up one, right one, and go that diagonal direction here. So there I've connected my points for my line for y equals x minus 4, and I can clearly see that the point that they connect, so these lines cross at one point, and it is the point, looks here like it is 5, 1, and that would be my solution. The solution would be 5, 1 for the system of equations. So these are really the 3 types of pictures you could get. You could get one answer, you could get no answer, or you could get an infinite number of solutions depending on how your system crosses your plane.